We're on lesson 3 of chapter 4, which is to write linear equations in point-slope form. So first we're going to graph an equation in point-slope form. Then we'll use a point-slope form to write an equation. Then we'll solve a real-world problem. When you first look at point-slope form, it might be a little intimidating. You see y plus 4 equals 2 times the difference of x and 2. And whenever you solve equations, you need to make it into a true statement. What helps you is that you know that 0 equals 0 is always a true statement. So you could ask yourself, how can I get this side to be 0? And how can I get this side to be 0? Well, I know that negative 4 plus 4 would be 0. And I know that 2 times 0 would be 0. So if it was positive 2 minus 2, that would also be 0. So that would turn this into 0 and 0. So my y would be negative 4, and my x would be positive 2. So 2 and negative 4 would be a true solution to this point-slope form equation. And we can use that idea of 0 equals 0 to solve these problems today. So it has us graph this equation. Y plus 2 equals the slope of 2/3 times x minus 3. How can I turn this into 0 and 0? Well, y will be easy. I just know that y plus 2, so negative 2 plus 2. So y equals negative 2. And then x would be 2/3 times 0 would be 0. So how I turn this into 0? It would be positive 3. So x would be positive 3. So my point that would go on the graph would be 3 and negative 2. So let's plot that. 3 and negative 2. So now what I can do, I know the slope. Now that I've found a point, I can use this slope to plot the other points then. It's a rise of 2 and a run of 3. So run of 3, rise of 2. Here's one spot. I can go backwards, right? Backwards 3, fall 2, which is the opposite direction. And there we have it. Once you have 3 points like this, I can just draw that line. Starting in this one, going through, and using point-slope form, I have just created a line. So let's use this graph to create a point-slope form equation now. First, we need to find the slope. So I see that the rise would be a fall of negative 2, and a run would be 2. So the rise over run would be negative 2 over 2, which would turn into negative 1. Now that I have my slope, I can use either of these points to help me write my point-slope form equation. Because a point-slope form equation equals y plus something, which we don't know yet, equals the slope, negative 1, and then in parentheses, x plus something. That's what it looked like as we worked on it last page. If we know these points, we can turn this into 0 equals 0. So let's do that. Let's use negative 1 for x. If x is negative 1, what would this have to be to turn it into 0? Negative 1 plus positive 1 would be 0. So let's do x plus 1. And then y. Y here is 3. So if y is 3, what would this need to be to turn it into 0? It would have to be negative 3. So it would be y plus negative 3. And here would be my point-slope form equation. Y plus negative 3, or I could write y minus 3, equals negative 1 times x plus 1. And that would create this line here. So we went backwards there. Just to recap, we found the slope by doing the rise over run. And then we used this point to determine how would I turn that into 0, 0. We determined that positive 3 for y would have to be subtracted by 3. We determined that negative 1 for x would have to be added by 1 to create 0, 0. And then that's our equation. So let's solve this problem then. You are a designer. You are designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers and $80 for each additional stickers. Write an equation that gives the total cost in dollars of stickers as a function of the number in thousands of the stickers ordered. Find the cost of 9,000 stickers. So I can solve this one because I know one point on the graph and I know the slope. I know one point in the graph because the first 1,000 stickers, if we're measuring in thousands, they say the first order of stickers would be $225. So if I'm going to write that as a point, I'm going to measure it in thousands, remember, so it'd be 1, remember measuring for 1,000, and 225. I also know the slope. It's $80 for each additional one, so it'd be 80x. And remember when we do point slope form, we know that 0 always equals 0, so that's a true statement. So if y is 225 here, I could have y minus 225, and that would be a true statement in this case. And then on the other hand, I have the slope of 80, so I'm going to start with 80 on the outside here, and then x minus 1 would be a true statement as well. So this would become my true statement point slope form equation. And this makes sense too, because I paid $225 for that first one, but that's not what I pay for the rest of them. As well as I do x minus 1 because the second order I place is actually the first one after this more expensive one. So I do need to subtract that first one because otherwise I'd do 2 times 80, but that wouldn't be true because I'm not paying $80 for the first one, I'm paying $225. So now we can solve this. I'm actually going to do C instead of Y because I'm actually measuring the cost. So now we can do a distributive property. So C minus 225 equals 80 times x, so 80x minus 80. So I can add 225 to both sides. Negative 80 plus 225 would be 145. So C equals 80x plus 145. And there we have it. We have our sloped intercept equation, which we all like to use. And now we can find the cost of 9,000 stickers. Remember, these are measured in thousands, so we would just plug in the number 9 for x. So C equals 80 times 9 plus 145. 80 times 9 would be 720. So 720 plus 145. And that would give us 865. C equals 865. So that's how much it would cost your band if you wanted to buy 9,000 stickers to advertise.